This is the LT-SPICE schematic for the transmitting circuit. This circuit takes input in the form of AC current through a microphone and aux cord. The microphone part of the transmitter is powered by a 4.5 volt DC source and uses a potentiometer to control the volume. The output from the microphone passes through a low-pass filter before entering a non-inverting op-amp to amplify the AC signal. This signal then goes through a capacitor to block any DC signal. The aux part of the transmitter contains only a potentiometer as volume control. These two signals then go to a summing op-amp through a pair of equal resistors in order to ensure that both signals contribute to an equal amount of the output from the transmitter. The output from the summing op-amp is powered by a bias T, which consists of an inductor connected to a positive 4.5 volt supply. This DC signal powers the laser that transmits the AC signal to the receiving portion of the circuit.
Okay, is that good? Yeah.
The receiving circuit consists of a photodiode that reads the signal from the laser. This signal is then sent through a capacitor in order to block any DC signal, and is then amplified using two op-amps. The first op-amp is inverting, and the second op-amp is non-inverting with a gain factor of 10, and both op-amps are powered by positive and negative 4.5 volts. This amplified signal is sent to the speaker through a potentiometer, which acts as overall volume control.
Receiving circuit. Yeah, it's John Cena.
Yeah.
I can always cut the video. Trying to get the best sound. Hold on.
Yeah, it's hard to aim it.
It's okay. Because it's like my photodiode is really specific where you hit it, so
Yeah.
that's why.
Yeah, I know all of them. It's like so annoying. Like. Yeah, that's so much better.
John Cena.
This frequency response graph was created by running signals ranging from 30 Hz to 70 kHz through the aux input of the transmitting circuit, and then via the laser to the photodiode on the receiving circuit. The voltage of the node directly in front of the speaker was then measured in relation to the common ground node for each frequency, and the data was plotted on the graph. The results show a bell curve, with signals in the 1 to 3 kHz range causing the highest peak voltage. These graphs are a result of running a 100 kHz sine wave through the entire circuit and measuring the oscillation readings at various points. The first graph depicts the signal that is output by the laser, the second graph depicts the signal that is put out to the rest of the receiving circuit by the photodiode, and the third graph shows the input of the signal through the speaker, which is the signal that we actually hear. As these graphs show, as the signal runs through the various parts of the circuit, it is distorted and changes slightly, causing noise, but the final output signal of the speaker still manages to maintain the same general shape as the aux input, resulting in the sound that we hear.